So today we're going back to working with fractions and turning them into decimals. Now, if you recall, a fraction is really a long division problem. So we're going to use long division to determine the decimal expansion of each of the following numbers without the use of a calculator. So going back to some long division. And I know that's tricky, but I promise you can do it. So I'm going to help you guys work through these four to remind you of how to do that long division. So 54 over 20 is the same as saying 54 divided by 20. So we put the 20 outside and we put the 54 inside. Now 20 goes into 54 a couple times. We know it goes into 54 twice because 20 times 2 is 40. So we bring down the 40 and we subtract and we get 14. 20 does not go into 14 and I don't have any whole numbers left. So we're going to put 0.0 and bring a decimal up as well. We're going to bring that 0 down. And we know that 20 goes into 147 times. So our answer is 2.7. And then we're done because we don't have anything else that we have to figure out. We have no remainders left. So 2.7 is our decimal expansion of 54 over 20. All right, number 2, we do the same way. We start with 7 over 8 is the same as 7 being divided by 8. So the 8 goes on the outside, 7 goes on the inside. Now in this case, 8 does not go into 7, so we're going to put a 0 and a decimal, and then a decimal and a 0 by the 70. So now we have to figure out how many times 8 goes into 70, ignoring that decimal there. And 8 goes into 70 8 times, which gives us 64. We subtract and we get 6. And we bring down another 0 because we still have a remainder there. Then we think about how many times 8 goes into 60, which would be 7, because 8 times 7 is 56. Then 60 minus 56 leaves us with 4. So we're not done yet. We need another 0. Bring down that 0. And we know that 8 goes into 45 times, because 8 times 5 is 40. And now we are finished since we have no remainder left over. So the decimal expansion of 7/8 is 0.875. All right, so now let's take a look at number 3 and number 4. They will get a little bit harder. So for number 3, we have 8 over 9, which means 8 is being divided by 9. So we're going to put 9 on the outside and 8 on the inside. And once again, 9 does not go in evenly to 8. So we're going to put a 0 and a decimal and a 0. And we think about how many times 9 goes into 80. And I know 9 times 9 is 81, so that's going to be too much. So I'm going to need an 8 here. And 9 times 8 is 72. Then by subtracting, we know 80 minus 72 is 8. So we got 8 again. And 9 again does not go into 8, so I have to bring down a 0. And once again, I get 80. And I know 9 times 8 is 72. Subtracting again, I'm left with 8. So hopefully that's a reminder that this is going to be a repeating decimal. So I don't have to keep on going. I could just express my answer as 0.88 repeating, or just 0.8 repeating. Remember, the bar over the number shows that it repeats. Okay, number 4, very similarly, now we have 22 over 7, which means that 7 is dividing 22. So 7 does go into 22, but not exactly. We know 7 times 3 is 21. Subtracting, we get 22 minus 21 is 1 left over. So now we're going to need a decimal and a 0. We bring down that 0. And 7 goes into 10 one time. So 7 times 1 is 7. And we subtract and we get 3. Bring down another 0. And we get 30. 7 goes into 30, but not exactly, so that's 4. And 7 times 4 is 28. And 30 minus 28 is 2. So I need another 0. Then I get 7 into 20, which doesn't go exactly, but 7 times 2 is 14, which is the closest I can get without going over. So that's going to be 14. Subtract and we get 6. So again, I need another 0. and I get 60. 7 goes into 60 8 times, which gives me 56, which leaves me with 4. So again, I need another 0, and I get 40. 7 does not go into 40 exactly, but 7 times 5 is 35, which is as close as I'm going to get, which leaves me with 5 left over. So I need another 0. I'm just going to bring it over here. And 7 does not go exactly into 50, but 7 times 7 gives us 49, which leaves us with 1 left over. And then if I were to bring up another 0, I would get 10, which is a number we saw before, right over here. So that means it's going to repeat the process all over again. So that means this whole entire thing is going to repeat. So it's 3.142857 all repeating, right? So that is a very long decimal. All right, so you're going to answer number 5 on your own. Write a complete sentence that describes how exercises 1 and 2 are different than exercises 3 and 4. So hopefully from that, you saw that the top 2 were repeating and the bottom 2 did not, or the top 2 were decimals that ended, where the bottom 2 were repeating numbers. So now we're going to change how we call those, what we call those types of numbers. A finite number is a decimal that terminates, terminating meaning it ends, like 2.7. While an infinite number is one that repeats, like 0.88888888. So we're going to learn how to convert numbers like those into fractions. Okay, so we have, or converting numbers that don't repeat into fractions. So we have the fraction, or into a decimal. We have the fraction 7/8 to a decimal using the following process. So you should remember from the past that if you have a power of 10 in the denominator, it's really easy to rewrite that number as a decimal. So for example, 8/10 is 0.8. 85 hundredths is 0.85. 825 hundredths, or thousandths rather, is 0.825. So that tells us how many places out each number should go. So 8 hundredths would be 0.08. 85 thousandths would be 0.085. Hopefully that's something you remember from the past and have committed to memory. So we're going to learn how to take the denominator and change it to a power of 10 so you can very quickly change it to a decimal without needing a calculator. So to do that, you're going to write a denominator of products of 2's or 5's, because 2 times 5 is going to give us 10. Then you're going to multiply the numerator and denominator by a common multiple that will make the denominator a power of 10. And then you're going to change the decimal the way I just described. All right, so in this case, we still first need to change the denominator to its factors of 2's and 5's. So we have 16, which is 2 times 8, 8, which is 2 times 4, and 4, which is 2 times 2. So this is 7 over 2 to the 4th power. Now, it has to be the same number of 2's and 5's. So I'm going to multiply this by 5 to the 4th over 5 to the 4th, which is essentially the same as just multiplying by 1, because I have the same number over itself. So I'm not really changing the value. So then I have 7 times 5 to the 4th over 2 times 5 to the 4th, which is 7 times 5 to the 4th over 10 to the 4th. So now I can use my calculator, and I can do 5 times 5 times 5 times 5 for 5 to the 4th. Which is 625. Multiply that by 7, and I get 4,375 over 10 to the 4th, which is a 1 with 4 zeros, or 10,000. And then I can write that as a decimal, There it means it needs to be 4 places back, and I have 4 digits, so my answer is 0.4375. Done. So I know it's easy just to use your calculator to convert it to a decimal, but you should be aware of this process and able to set it up. All right, so for the next one, we have 9 over 25. Now, 25 is 5 times 5. There's my 5s. So it's going to be 9 over 5 squared. Now, again, I need the same number of 2's. So I'm going to multiply by 2 squared over 2 squared. That's going to give me 9 times 2 squared over 5 times 2 all squared, which is 9 times 4 over 10 squared, which is 36 over 100. So that means I need to have my decimal 2 places back. So my final answer is 0.36, 36 hundredths. The last number should be in the hundredths place. All right, let's continue with this idea. So for number 9, we start by making a factor tree of 32. 32 is 2 and 16. 16 is 2 and 8. 8 is 2 and 4. And 4 is 2 and 2. So it's 1, 2, 3, 4, 5 2's. So we have 3 over 2 to the 5th. So I need the same number of 5's. So that's going to be 5 to the 5th over 5 to the 5th. So I'm not really changing the product or the whole fraction. So we get 3 times 5 to the 5th over 10 to the 5th. 10 to the 5th is a 1 with 5 zeros, or 100,000. And then I just have to do that 3 times 5 to the 5th, which is 3 times 1, 2, 3, 4, 5 5's, which is 9,375. And I've got 5 places that I need to have as decimals and only 4 digits in the numerator. So it's going to be 0.09375, or 9,375 hundred thousandths. Okay, let's take a look at number 10 together and do the same process again. So 125 is 5 times 25, and 25 is 5 times 5, so it's 5 to the 3rd. And I need the same number of 2's, so we're going to multiply by 2 to the 3rd. So that's 11 times 2 to the 3rd is 2 times 2 times 2, or 8, over 10 to the 3rd, which is 88 over a 1 with 3 zeros, or 1,000. 88 thousandths gives us 3 places for decimals after the decimal place. And I only have 2 digits, so it's going to be 0.088, or 88 thousandths. All right, so we have 2 more to go, and these 2 are a little bit more challenging. So taking a look at the first one, or number 11 rather, we have 1 over 40. So we have to start by making our factor tree of 40. So 40 is 2 times 20. 20 is 2 times 10, and 10 is 2 times 5. So we get 1 over 1, 2, 3 2's, 2 to the 3rd, and 1 5 times 5. So this is more challenging now because I have 2's and 5's. I need to balance those 2's and 5's. In order to have this 5 be the same exponent, I need 2 more, so 5 squared, which means I'm also going to multiply the numerator by 5 squared. So that gives me 1 times 25 over 10 to the 3rd, which is 25 over 1,000. There's 3 places after the decimal because of the 1,000, but I only have 2 digits, so my final answer is 0.025, or 25 thousandths. Okay, the last one is similar to that. I have 200 as my denominator. So we're going to write that as our factor tree first. We get 2 times 100 And 100 is 2 times 50. And 50 is 2 times 25. And 25 is 5 times 5. So we have 9 over 1, 2, 3 2's, 2 to the third, times 2 5's, 5 squared. I need to balance my 2's and 5's, so I need one more 5. Whatever I do in the denominator, I have to do in the numerator to keep it the same. So that gives me 9 times 5, which is 45, over 10 to the third, which is 45 over 1,000. And again, I have 3 zeros here, so I need 3 places behind the decimal, which is going to give me 0.045 or 45 thousandths as my final answer. So for tonight's homework, you have to show that process to get full credit. I know it's tricky, but it's going to make you build your number sense and really understand how these fractions are related to the actual decimal number. All right, so take your time, answer your exit tickets, and then you can get started on your homework.